Hey there, I'm Nancy and welcome to the OWASP DevSlop Show. Our guest today is Senior Developer Advocate at Hashicorp, Rob Barnes. Hi, Rob.
Hiya.
So what do you have prepared for us today?
So we've got a fun session. So we're going to be looking at secrets management from a developer's point of view. We'll look at some of the challenges that developers face when it comes to secrets management, what it means for developers, and how we can solve some of those problems. I don't want to spoil it too much. We'll get into it in a bit.
Sounds great. But first, a message from our sponsor, Salvo. Hey, we're Salvo, and we're the first adaptive solution to manage your cloud security automatically. Salvo creates unique security configurations based on each environment, its needs, and its application. Salvo enforces the least privileged configuration that was created for you automatically and early on the left side of the life cycle. Salvo enables you to view and control your infrastructure, inventory, security posture, and risk. We protect, we automate, we optimize, we solve. Salvo.
Welcome. I'm Faith, and I'm here with my lovely co-hosts, Shanisa Kembrick.
Hello.
And Nikki Becker.
Hey, everyone.
If you're new here, please make sure to subscribe and enable your notifications. All important information that we'll discuss today will be added to the description box below.
Thanks, Faith. Hey, Shanisa. It's your first time co-hosting today, so we're really happy to have you. You want to tell us a little bit about yourself, just so our audience can get to know who you are a little bit?
Yeah, so thank you very much. I appreciate the introduction. I appreciate the opportunity to be here. So Shanisa Kembrick, I've been in the IT industry for over 15 years. I have worn many different hats, from developer to application security, identity access management, and I currently lead a team of security architects who do everything from on-prem security to cloud security. And looking forward to the chat today. Thank you.
Thank you. Wow, you sound really well-rounded. You'll fit in perfectly here as a co-host.
Pretty
cool.
tired.
So let's go ahead. All right, let's go ahead and meet our guest. So Robert, also known as DevOps Rob, is a senior developer advocate at Hashicorp. His focus is primarily on cloud security. He comes from a network engineering background, and more recently in his career, he has been working as a cloud consultant, helping customers extract maximum value from the cloud. He's a strong advocate for open source, security best practices, and building diverse communities. Hey, Rob.
Hey. Yeah. It's great to meet you all. Thanks for having me. How are you all doing?
Thanks for being here. Yeah, we're doing great. All right.
Amazing. It's going to be a good session. I'm quite happy to have this type of company. Awesome. Okay, cool. So just want to say once again, thank you for having me here. It's a pleasure. This session's actually been in the works since I think middle of last year. So I'm glad to finally be here and connect with you all. And hopefully it's the first of many collaborations between us. So today, as the slide says, we're going to be talking a bit about secrets management, specifically from a developer's perspective. So with that, let's just go ahead and run through the agenda. Okay, so firstly, we're going to look at what secrets management is from a more high-level, kind of broader kind of view. And then we're going to move the conversation into something that's a bit more specific towards developers and how they may see secrets management, some of the challenges that they can face, and sort of understand why they're challenges. And just on that note there, I'll just say that in my experience, I didn't even know what secrets management was many years ago, and didn't realize I had some of the problems that we're going to discuss today, just because we had learned to accept normal things until the worst happens, you know. So it's just kind of highlighting some of these things and showing what we can do about it. We'll also then go ahead and look at how we can solve some of these challenges. So, you know, the challenges are far and wide. So we can't cover them all today, but we'll just pick a couple and just kind of zero in on those ones there. And then the bit that probably everyone's most excited about is the live demos. So, you know, we've got some PowerPoint, but we're going to end up in the terminal. So, yeah, I'm looking forward to that. I'm sure you are too. So just to kind of introduce myself, I know I've already been introduced, but I've got this slide, so I don't want to waste it. You know, I'm Rob. Call me Robert if I'm in trouble, but no, Rob or Robert is fine. In the tech community, and more recently in the gaming community, I'm also known as DevOps Rob. Long story behind that, maybe I'll tell you another time. So I'm a senior developer advocate at a company called Hashicorp. Hashicorp make a bunch of developer and operator tools. So we have things like Terraform, Vault, Packer, Nomad, Vagrant, just a lot of things that help ease developer problems and help them with their workflows. And basically what it means being a developer advocate to me is essentially just learning in public and teaching what I learn. So, you know, I don't view myself as an expert. I kind of view myself as a community member. So everything that I'm going to show today is things that I've learned through my years of experience, or things that other practitioners have taught me, or I've stumbled across in some cases. So yeah, that's a bit about me. Self-promotion time. I need to promo myself a little bit more. So I'm on Twitter. So definitely drop me a follow on Twitter. It's at DevOps_Rob. I also am on YouTube as well. So, you know, if you want to see content like this, for example, definitely give my channel a subscribe. It's just DevOps Rob. And also GitHub is an important one, especially for today's session. Some of the demo code that you're going to see today, I will be publishing it to GitHub. So definitely drop me a follow there so you can be notified when that is live. Right, and without any further ado, let's get straight into it. So the question, what does secrets management mean to developers? So I think maybe what we'll do is we'll define secrets management in a more larger context first, before we start relating it to developers. So, you know, in my opinion, secrets management is concerned with three kind of main themes. And the first one will be identity and access management. If you're not too familiar with that, I actually have some stuff on my YouTube where I talk about the principles and fundamentals of identity and access management. So definitely check that out. But that's a huge area where we're looking at brokering access to other systems. We're looking at controlling how we can authenticate people and applications, and how we can authorize their access to and from different services and data. Right? We're also looking at things like secret storage. So, you know, that traditional things like in the cloud, you have, I think, what they call it, Secrets Manager in AWS, where you can just store a static secret, and anytime you want it, you can just reference it from there. So secrets management is also largely centered around that as well. And the third area, which isn't spoken about so much, but I've found it to be more the case as I continue to work, is data security, right? So what I'm talking about that is when you have data that your application is producing, how do you know that the data you're reading back is actually valid data and it's not sort of been inserted by a malicious actor? So how secrets management can, you know, control some of the validity of this data is something that I think we need to speak about a bit more. So I think we're going to cover some of that today, but it's probably more for another session in the future. Now, some of the things that I've mentioned aren't necessarily developer problems, but security is everyone's responsibility. And, you know, there are elements of secrets management that directly impact developers. And for this reason, you know, we build applications which are consumers of secrets management. So I think we have to have some awareness of what some of these challenges are, especially where they cross into our world as developers. So in terms of some of the challenges, I've actually split them up into two different sections, just to kind of maybe not go down the whole division of responsibility, but just to kind of see that some things are ops problems, but we should care about them, and some things are more centered around developers. Right? So, you know, if we start with the ops side of things, we have like cloud authentication. So what I mean by that is anytime where our applications need to interact with cloud resources, we need to provide some kind of authentication details for our applications to auth against the cloud provider. So some examples of that would be, I think in Azure, we have service principal. So you'd need to configure that within your application. GCP uses either service accounts or OAuth tokens. So again, you'd need to configure all of that into your application workflow. And I think AWS is a combination of an access key and a secret access key. And I think they have some other authentication mechanisms built in. But the point is the application is going to need these details to interact with the respective cloud resources. And I can give sort of a practical example of that. If you are using like a cloud KMS, for example, so I think Azure has Azure Key Vault. You're going to need to be able to authenticate against Azure to be able to interact with Azure Key Vault there. And in order to do that, you're going to need the authentication details. Moving on, I put database authentication, but actually this could be anything, right? But generally speaking, with our applications, when they need to connect to a database, we need to provide a connection string. And I stress this is a very broad statement there. I'm aware that there are different flavors of database where connectivity is a little bit different, but generally speaking, we need a connection string. Within that connection string, it normally includes a database user and a password. And that's what your application is going to use to make a connection to the endpoint that's specified within the connection string. So we have the challenge as developers of how do we manage that within our application code. Now, this is another prime example of, yeah, it's typically an ops problem, but you know, it's our code and our code is going to have to handle that. So we should be aware of it and we should know ways which we can work with the ops teams to solve this challenge. The third challenge I've put down, again, it's just another flavor of what I've just mentioned, but things like message queue systems. So the challenge is the same here too. You know, we need to provide login details for our applications to be able to authenticate with them. You know, it doesn't matter what you're using. It could be RabbitmQ, it could be Kafka, MSNQ, Azure Service Bus. It really doesn't matter. They're always going to have to give some type of details for them to authenticate with the message queue systems. You know, and I could substitute message queue systems with any other third-party system that your application needs to interact with, right?
I guess you could always configure. I was going to.
Sorry, go ahead.
But you could always configure the Kafka to have no authentication, and then you kind of solve the problem. Just kidding.
There's actually a better way than that. What you can do with something like RabbitmQ, for example, is you can use the default username and password, not change it, and you're good to go. You could just Google it, right?
Yeah.
I just be clear, that's actually a joke. No way. I have professionals here, and I know that they are turning over inside hearing me say that. Do not do that. Please do not do that. Right. So let's look at some of the developer challenges. Right. So as developers, you know, like some of the things that we come across in our application is, you know, it's mainly around the data. So I'll give you an example. In the UK, we have something called GDPR laws. I'm not sure if you have that in Canada or the US, but it's all about data protection and the responsibilities of companies when they're handling your personally identifiable information, or we call it PII, right? And what these laws state is that the organizations that are handling your data need to handle it with due care and for its security, right? So for the most part, what that means for us as developers is we need to probably encrypt our application data while it's in transit and at rest. And that's like sort of the main way you'd go about protecting that PII data, right? You know, the challenge around that is, we'll talk about that in a bit more detail in a few minutes, but we're talking about cryptography, and yeah, cryptography is hard. It's just the easiest way to sum it up. It's complicated, and as a developer, we don't really want to have to concern ourselves with it, but we need, our worlds are crossing over into that. We need to know about how we can protect our application data, right? The second thing, which I alluded to a little earlier on, is data validation. So there will be use cases that we run into as developers where we need to sign data, for example, with a cryptographic key, and we need to verify the combination of the data and the signature to make sure that it's actually authentic. We actually have an example of that. So my buddies and I from Hashicorp, we did a keynote for HashiConf in the summer, I think it was, and we actually built our own blockchain and a cryptocurrency called Hashicorp Coin, whereby we take some ASCII art and then we sign it with a cryptographic key, and we have the signature. And you only have the valid cryptocurrency when you possess the combination of the valid signature and the data together, right? So, you may come into scenarios where you need to solve that problem as well. And finally, I say finally, that's in terms of what I've got on the slide, but like I mentioned before, the problems are a lot wider than this, but I only have an hour. We have to look at authentication workflows. Now, what I mean by that is, as our applications handle more and more data, we need a way to be able to implement robust authentication workflows that allow us to control who is accessing what data, right? So we often, in order to protect ourselves, need to add additional layers of authentication for our application users beyond username and password combinations. And implementing some of these things can be challenging. Now, I've got actually a practical example that happened to me just this week. So it hits close to home when it's like this. Someone tried to steal some money from my bank account maybe 4 days ago. And the only reason why they did not succeed is because my bank account has two-factor authentication. So, they were able to get past the first step of withdrawing the money. But in order to confirm that, there was a one-time password that was sent to me, and they need to supply that. And if they don't have that, then the transaction cannot be completed. So in that scenario there, I was able to contact my bank and say, hey, that's not me. And they could put a stop to it. And, I have layers of protection. So, as we build our applications, we're not only thinking about how can we protect ourselves as an organization, but we need to think about how we can protect our customers as well. And things like enabling two-factor authentication for them when they're interacting with our applications is quite key. So let's drill down a little bit more. Yeah,
Rob,
go ahead.
I see the encryption and authentication challenges also relevant with ops. So not just a developer challenge, right?
100%. I think that's true. I guess what I'm trying to say is the problems do affect ops as well as developers. Though as developers, there are things that we should care more about. I think in general, I've worked with a lot of developers that they don't see a lot of these things as their problem. I guess the point I'm trying to make is it is your problem as well. There's always going to be an operations person there in the background who is losing sleep over some of these things, who is trying to implement workflows that are going to enable you as developers to, still care about it, but not have to put so much effort into it to deliver the same kind of robust protections for yourself as an organization and for your customers. So I think you're absolutely spot on with that. In terms of how you go about solving some of these problems there, I think a lot of the time the solution will come from developers or DevOps engineers, people that have the kind of know-how with operations and development. But we will get into that, I think. But kind of, that was really good you asked that question, because it segues onto this next bit that we're going to talk about, which is some of the challenges with implementing encryption yourself, right? So when we're talking about encrypting data, some of the challenges that you can come across is things like vulnerabilities in external libraries that you depend on, right? So you're using a library that's really popular and it's got loads of stars on GitHub and it seems well tested, and that's really good. But then the moment there's a vulnerability in that is going to affect your application as well. So if you're using these libraries as a developer, you are now responsible for being able to patch these things. And, you know, some of these things may be beyond your control just because you're not sort of the owner of that library. Maybe you're not able to patch things so quickly, and it leaves you a bit more vulnerable. So, you know, having this dependency on open source libraries out there is something that is acceptable for some organizations, but for others, it's not. And it's all about the scope of responsibility that you want to take on. I'm not saying using external libraries is bad or good in that sense. It's just about how much responsibility do you want to accept for that, right? The second thing is key management. So, you know, in cryptography, we're talking about cryptographic keys. And you have the challenge of where you're going to store these cryptographic keys. You know, how are you going to ensure that the keys are stored securely? How are you going to govern and control access to these keys? These are like really challenging things, you know, and if you're going to implement cryptography by yourself, this becomes your problem, right? So now you're going beyond developing your application and then having encryption on there. You now have this massive security and operations problem where you need to store these keys, you need to rotate keys, you need to govern access to these keys, you need to be able to do all these types of things. And, you know, in a lot of cases, there are a lot of developers, myself included, who just don't have the experience or knowledge of how to do these things, right? The other thing I'll say is testing, right? How do you implement unit testing, for example, on your cryptographic implementations, right? How do you do wider smoke tests and all these different testing strategies that you may employ? How do you do that? How do you know that your tests are efficient? Because, you know, if you're not experienced at this, if you don't kind of focus on these areas here, then you kind of leave yourself open to making mistakes, right? Which is ultimately what I'm trying to say here, right? Implementing cryptography, it can be error prone, and there are so many steps along the way where it's easy to make mistakes, right? And those mistakes lead to vulnerabilities in your application, right? So the point is, I said it earlier and I'll repeat it, cryptography is hard. It's really, really hard, you know, and as a developer, I don't want to care about that, you know? So these are some of the challenges that you kind of face when it comes to implementing your own cryptography. Looking at application workflows, let's look at some of the challenges there. So, you know, in general, we build applications for one of two reasons, generally speaking, right? So you're either trying to solve a problem or you're trying to seize an opportunity, right? Generally speaking, what we're trying to do is provide some type of convenience or make something accessible or maybe more accessible to a group of people, provide new functionality or improve efficiency of existing processes, right? Whatever the reason behind an application, there's no denying that as humans, we have become quite reliant on some of these applications. You know, our lives have become so intertwined with how these applications work that if these things aren't protected properly, the impact it has on our lives are a lot greater today than they've ever been before, right? They underpin the way we live life. And, you know, I can give the example of a banking application, right? I can't remember the last time I walked into a bank or even went to a cash machine, right? It's something I don't need to do anymore. You know, if I need to do banking, I could just pull out my phone, I can use the biometric authentication that's built in there, and I can manage my money. I can send payments, I can check that I've received payments, I can manage my household bills, anything I need to do. And, you know, the world is moving cashless, so I don't really need to go to a cash machine or anything like that. So as a consumer, it's a win for me because now I don't need to get in my car and drive to the bank and wait in the queue and do what I'm doing and then do the same thing in reverse. Now I can just do it on my phone. So if authentication of that banking app, for example, is flawed, just like the real life example that I've given from earlier on this week that I've had to go through, then, you know, the impact on this is that, you know, someone would have stolen a chunk of my money. I would now have to waste a lot of time speaking to the bank, trying to get that sorted out so I can get the money back through the government insurance schemes and so on and so forth. And, you know, that's time that I wouldn't have had to spend working on my demos and presentation that I'm giving to you right now. So, you know, it has a huge impact. And, you know, it meant I probably would have had to pull out of this if I spent too much time doing that. And that affects a lot more people. So the importance of building robust authentication workflows into your applications has never been higher, in my opinion. Right? So, those are like, in terms of the developer's point of view, I've kind of looked at 2 problems there out of so many. So we're going to look at Hashicorp Vault, which is a product that I use at work. It's the product I advocate for. I was actually an advocate for Hashicorp Vault long before I joined Hashicorp, because as a cloud consultant, it helped me solve a lot of my client problems in a way that suited their cloud strategies, right? So, how can Vault solve some of these problems, right? In terms of what Vault is, that's probably the best place to start. So the simplest way of putting it, and it's the way that most people would describe it, is it's a secrets management platform, right? But to me, it's a lot more than that, right? It's sort of a centralized security hub. It's a secret store, it's an identity broker, and it provides you cryptography as a service, right? So, in the demo that I'm going to come to shortly, what I'm going to show you is, as developers, how you can leverage Vault's API to encrypt and decrypt application data and implement 2-factor authentication using a one-time password, right? So how we're going to go about doing that is, Vault has the concept of secrets engines, right? So we have a secrets engine in terms of the cryptography that we're going to use, and we call that the transit secrets engine. I think originally the name comes from, it was designed to encrypt data in transit. So we're going to look at how we can leverage this really powerful element of Vault to help us not have to care so much about some of these challenges that we've gone through. And we're also going to use another secrets engine, which is going to help us implement 2-factor authentication for our applications. And I think I've never actually heard anyone pronounce the name of it, so I'm just going to call it TOTP, right? So I don't know what the first T is standing for, but the rest of the acronym is standing for one-time password, right? So we'll go into that. So it's actually 2 demos I've got for you today. So I just want to kind of walk you through some of the architecture and the workflows that we're going to be implementing here, right? So from a high level, we have 4 components here in this first demo. So we have a producer service. We're in a distributed world now. People are creating microservices and they have to interact with other services. And our producer service is one of those things that needs to do something, right? And that something it needs to do is place some kind of data on a message queue. So we have RabbitmQ as the second component, right, acting as our message queue, right? And then we have another service, which is a consumer. And what that consumer needs to do is it needs to consume messages from that message queue to do whatever it is it needs to do with that, right? Now, if we just kind of walk through that workflow, the first thing that the producer is going to do is it's going to go to Vault and say, can you give me some credentials for RabbitmQ? Now, if you remember a couple of slides ago, I said that I see Vault as an identity broker, right? So what's going to happen is it's going to ask Vault for these credentials, and then Vault is going to go into RabbitmQ. It's going to create some credentials, and it's going to serve it to that producer service, right? And then with that, it's going to be able to then go back to Vault and say, hey, I have some data here. Can you encrypt this for us, right? And then it's going to encrypt that data and send it back to the application. The application is then going to take those credentials that it provisioned in the first step, and it's going to connect with RabbitmQ, and it's going to place that data, which is encrypted, on the queue, right? Without this mechanism, before I even continue with the workflow, the data you'd be placing on there would be in plain text for anyone who has access to that queue to be able to see, right? So now, one of the challenges you have there is if your message queue becomes exposed for whatever reason or vulnerable, you now have potentially sensitive data that is available to whoever's exposed it there. Right. So now, once that message, which is, sorry, go ahead.
Yeah, real quick on that diagram again, Vault is smart enough to know that this new microservice needs credentials, goes and requests fresh credentials from RabbitmQ, stores them in the vault so that producer can now access them. So it's smart enough to like actually provision the account.
Sort of,
or
yeah.
Am I missing
so
okay.
No. You've kind of, but I just want to make sure that what I say is not misconstrued, right? So what you're doing when this is not really the developer's problem, but it's it's good for a developer to know what's happening in the background, right? So someone in operations would have configured Vault with connectivity details to RabbitmQ, right? And those details are going to include a highly privileged account, which has the ability to manage users on RabbitmQ's behalf, right? So it has that functionality built in, right? And that's, it's write only. So once operations have configured that, no one can go into Vault and then read those credentials again, right? You can only write new credentials, right? So once it's got that, now what the producer can do is it can make a call to Vault and say, hey, I need some credentials. And because Vault knows how to talk to RabbitmQ, it can then go in, authenticate, create a new account with the permissions that you've specified. Again, that's what ops will configure that for you. And it will just serve your application with that. So what you're doing in the producer element of your application is you're just building a bunch of API calls, which implements that workflow there, which says, hey, give me a bunch of credentials using this role. And a role is just about the permissions that RabbitmQ is going to give to the credentials that are provisioned. And then it would then use those credentials to go ahead and connect to RabbitmQ. Now, again, it's not really developers' problem, but I'll just say this. These credentials that Vault generates, they are short-lived, or ephemeral credentials is another term that we use. What that means is it has a lifespan. So let's just say a credential is going to last for 30 minutes, right? So Vault will go in, create that, and then it will start the clock on those credentials, right? So it serves it to the application. The moment the time to live, or the TTL, expires on those credentials, Vault then goes back to RabbitmQ and cleans up the mess. It removes that account. So one of the real value propositions here is the fact that you now don't have secrets sprawled all over the place. Because without that mechanism, what you'd have is Vault provisioning a bunch of accounts, and then you just have a really long list of accounts, and you now can't track who's got what, and where a vulnerability exists, or where if you have a breach, for example, where did it stem from? What we're doing here is we're reducing blast radius, right? So like I say, it's primarily an ops and a security problem, how you implement that part there. So all the developer needs to know is that it exists, that they'll tell you, you'll tell them what you need to do. So I need to access this exchange, and I need to post messages to this queue, for example. And ops will turn around and say, okay, don't worry, I've got you covered. And then they'll create a role if one doesn't already exist, which has the permissions specific to what that producer service needs, right?
Yeah.
So does that kind of answer your question?
Yeah, and definitely in terms of separation of concerns. Developer just needs the credentials. That's the primary problem you're solving. The onboarding on the back end, I get it. It's a totally separate team. And there's just different concerns there. So yeah, makes sense to me. And there was a question in the chat before we move on that I just want to hit you with first. Yes. It is a question around, where are the credentials to Access Vault stored? So yeah.
That is my favorite question. So what we're talking about here is we're talking about secure introduction of secret zero, right? Now, in my opinion, that is very much not a solved problem, right? I haven't seen anyone really do something that's slick enough to really solve that problem across the board, right? So there are some things that we can do. So it just kind of depends on the architecture of your application. So you'll see in my demo that I'm using environment variables to do that, which I'm not the greatest fan of that, but for demo purposes that will work. But ultimately, when it comes to the secure introduction of secret zero, you're going to have to delegate trust to a system that your organization trusts, right? So some organizations will turn around and say they trust their CI/CD pipelines and the systems around that implement these pipelines. So what that will do is it will inject it into the application, maybe at build time or whatever it is. It's just entirely depends on the security posture of your organization. In Vault, we have an authentication method. So auth methods are it's like our bring your own identity provider kind of pluggable approach to authentication, right? But one of the things that we have is something called app role, which is okay, but it still has a few challenges that I've actually been working on more recently to try and solve, whereby you provision a bunch of policies in Vault, and those policies will say that any service that's using this app role, this is what it can access within Vault, right? And then you build the workflow into your application where it goes to Vault with the role ID, and then it says, hey, give me a secret ID, and then it goes and logs in with a combination of the two. And then you have some sort of restrictions you can put on that. So you can say that authentications can only come from this CEDAR range, right? So you can lock it down to IPs. But that's one of the challenges that I have with it is that maybe worked 10 years ago when there was still huge amounts of companies in data centers, and there still are huge companies in data centers, right? But even a lot of those companies, they're looking at their cloud strategy over the next 15, 20 years, and they're starting to move some workloads to the cloud. So the problem with that type of approach is it relies on having predictable static IP addresses. And as we know, if you're using microservices, which it seems like everyone's moving in that direction, things are a lot more dynamic. You can't really predict the IP address. You can't predict the port that applications are going to communicate to and from. So there's definitely a challenge there that we as a community need to solve. And like I say, I've been writing a paper and been engaging with some of our cryptography experts and product managers within Hashicorp, just with some ideas that I have around that. And I'm probably going to write that into a blog as well. So definitely watch this space, because even if we don't solve that, it'd be good for someone to read kind of what I've thought about, what I've tried, what we found, what didn't work and why. And maybe that will spur someone else to think in a different way. But that is a great question. And I don't have a silver bullet for that. I don't think anyone has a silver bullet for that. It's a huge problem in security. I'm sure some of my fellow panel members who work in security will kind of echo the same kind of sentiments. It's something that we scratch our heads about every day, and we've been trying to solve it for years. So sorry, I don't have a good one for that. But yeah, I think. Sorry, go ahead.
Rob. Sorry, with regards to the time-based authentication, so let's say within the 30 minutes, the producer still wants an additional set of credentials, or still wants to access the consumer. What then will happen? Will the producer have to go through the same cycle, or is there like a token that is given to the producer for that time duration?
So there's a couple of different ways you can do this, right? So again, this is why it's important. Even I don't see this as a developer problem, but it's important for a developer to understand these things, because operations cannot implement a solution if they do not understand your needs, right? So there are a couple of ways. The first way you can do it is some tokens have the ability to renew themselves, right? So it's all about the type of token that you provision, right? So tokens is the primary authentication mechanism within Vault, right? If whatever auth method it is, if you're using LDAP, for example, you bring in your own identity or Okta or something like that, whatever happens in the end, you're going to exchange that identity for a token, and the token is going to have policies associated with it, right? So when it's all said and done, it's tokens that matter, right? So some tokens have the ability to renew themselves. So if that's the case, you could just build that into your application's workflow. So rather than saying, hey, give me a credential, you could say, hey, do I have a valid credential? And if not, provision this. So you just kind of run your if statements accordingly, right? The other way you can do it is you have another type of token, which I can't for the life of me remember what it's called. I can't remember what it's called, but basically it like auto renews by itself, right? So you have like a sort of a set time period, and then when that time period elapses, then it will go ahead and renew itself. So that's another way you can do it. But it's down to your Vault operators to understand how your application is going to behave, and then provision the correct token type for you. That's gonna, you don't want outages because it can't authenticate with Vault, or it can't get the credentials to authenticate with a third-party system. So, you need to understand these types of things before you start to refactor your applications to include something like Vault. Does that really answer the question for you?
Yeah, thank you.
Amazing. Okay, so looking at the other side of this diagram, it's a pretty similar story. You have a consumer service, and the consumer service is doing the same thing. It's getting some creds from Vault, and it's using those creds to log into RabbitmQ to consume the message that's been placed on the queue by the producer, right? Now, then it's going to take that message and it's going to decrypt it using the transit secrets engine in Vault. And then now it's got access to the plain text data. It can do whatever it is that the service is designed to do. So, you know, we have a few moving parts and it might seem a bit complicated, but I promise you it's a lot simpler and you'll kind of see it in the code, right? The next thing that we have is this is the next demo. This is about the authentication workflows. So now this actually looks a hell of a lot more complicated than the code. Like literally the code is just not many lines, right? But essentially it's all centered around a user onboarding service, right? So the idea is that you have an application and you're trying to onboard users to it. So let's just take social media, for example. You have users who register for your application, right? And as part of that registration process, what's going to happen is that service is going to go to Vault and it's going to create a key for that user, right? So it's going to be one key per user in this workflow, right? And then once it's got that key, it's going to pass a QR code for a one-time password back to the service. And then it will just serve that up to the user, say, hey, here's a QR code. I think a lot of us are familiar with, if we've got things like Google Authenticator apps on our phone, it would be a similar kind of workflow. So then the user will then take that QR code, they'll scan it with on their phone with something like Google Auth or 1Password is another one that you can use for this. And then once it's done that, you now have a time-based I think it's a 6-digit code, which is going to rotate in our example here, every 30 seconds, right? You can configure that for as long or as short as you need, right? So you just have to be pragmatic in your design, right? So now you've got this rotating thing. What the onboarding service can then do to make sure that it's all valid is it can then ask you to input the code that you see on the application. And then it takes that code and goes to Vault and says, hey, is it valid? And Vault will turn around and say, yes, it's valid, or no, it's not. And you know, these codes have things that are nice built into it where you can only use the code once. So if you've used it once and you're still within, say, the 30 seconds for this example, and you try to use it again, Vault will say it's a one-time use password, right? So you can't use it again, wait for it to refresh and go again, right? So there's a lot of steps here in this diagram, but I promise you it's a lot simpler than that, right? And you're just leveraging just one secrets engine in Vault, which is the TOTP secrets engine. And it's really amazing. So with that, let's just slide over to the terminal. And let's get cracking with this demo. So I think everyone can see my code is quite big enough for everyone, I hope. If it's not, let me know, yep. I'll increase it. But here, what we have is I've written this in Bash. And the reason why I've done it in Bash is because I don't really know what languages people code in. I don't know. I tend to use Python and Go. There might be some Java people out there or C#. So I didn't really I wanted to be as inclusive as possible. And I think the lowest common denominator is Bash. I think most people are somewhat comfortable with Bash. So I've just done that. And all this code is going to use is 3 things, right? It's going to use curl just to make API calls. It's going to use JQ just to manage some of the JSON data. It's quite popular in Bash using JQ. And base64 to encode and decode certain things. And I'll explain that as we go along, right? So here we have this producer script, right? And this here is just kind of pertaining to the question that I was asked earlier on, right? So how do you get the token for Vault into your application, right? So at the moment, I'm just kind of putting it in as an environment variable. Do not hard code this into your code. That is not the best practice here, right? This is just a demo, and that's the only part I'll say don't do. The rest of it is perfectly fine. So we're just setting a few environment variables. So it's mainly the token, which we're going to auth with Vault against, and we have the address for Vault that we'll make the API calls with, and also RabbitmQ as well, right? So we don't actually need to do this because I've already configured RabbitmQ. But the first thing that we want to do is we want to create let's just make this a bit bigger so you can see this section. altogether, right? What we want to do is we want to go to Vault and say, hey, can you give us some credentials? So as a developer, all you need to know is that the role you need to get these credentials is called DevSlop, right? Now, you wouldn't have to configure that. Someone in Ops would have configured that and said, hey, yeah, if you need credentials for RabbitmQ for this application, there's a role called DevSlop, right? So here, we're just passing in the token in our header, you're just using curl. And we're just making a call to this endpoint here. So, everything in Vault is path-based, whether you're using the API or the CLI, it's all a consistent workflow. So the secrets engine is RabbitmQ. We want to request some creds, and the creds we want to generate are against this role called DevSlop, right? So if we run that, I'll just run that in here. And it looks like my keyboard is not working, so that's not great. Give me a second. I love technical difficulties during the demo.
It always happens.
Always happens. But fear not, I have a backup keyboard. Give me a second. If all else fails, use the one that comes with the computer. Right, let's just switch this on.
So Rob, as you're getting that plugged in,
yeah,
what
go ahead.
do you feel is the value add of Hashicorp Vault? So there's different vaulting tools, and you referenced a few, from Azure, AWS. So what's the value add from this tool?
For me, the value add is, if it depends on what your long-term cloud strategy is. If you're a Microsoft Gold partner, for example, then the chances are you're going to be in Azure, and the chances of you moving to another cloud or even splitting your workloads are pretty minimal, because there are some commercial reasons why you wouldn't, right? But there are a lot of companies out there who have some type of multi-cloud strategy. They have some workloads in one cloud and some workloads in another cloud. And what you want then is a consistent workflow for your developers, for your operators, no matter what the cloud is. So what you have is a centralized secrets management solution, and this will talk to all of these different clouds for you. And it goes beyond clouds as well. We're talking platforms as well. Whether you're using Kubernetes or you're using Nomad as schedulers, it doesn't really matter. You can not have to worry about how your secrets management is going to be impacted if you were to move to another cloud, because it's all a single workflow. And the other thing is training. You don't need to train sort of your operators with the specifics of one thing and then have to relearn it if you're moving to another thing. So for me, that's the real value add. It's a cloud first approach, which is inclusive and universal for all the clouds, basically. It's probably a lot deeper than that. There's probably marketing people in the background listening and screaming, saying, you forgot to mention this. But as a practitioner myself, that is one of the things that I go into organizations. I see that they're currently in this cloud, but they have sort of a 3-year plan to move this to that cloud. And you want to start thinking about these things if that's what you want to do. I don't know, have you come across any other use cases in your experience?
Yeah, I think you hit the nail on the head with the multi-cloud approach. So a lot of companies may have started off with one cloud, but they're going towards the multi-cloud approach, just based on the different functionality that you can get from various cloud vendors. So having a centralized tool, like you mentioned, I think is really going to help with that.
Yeah, 100%. There's also things that commercial things like cost, for example. If you're going to save so many thousands or millions in some cases by moving to another cloud, which is expensive to move, by the way. So it's not as simple as, oh, you get it cheaper here. Some companies will make those decisions because ultimately when you start to put your workloads on a cloud, what you're doing is you're entering into a technical partnership with that cloud provider. And sometimes partnerships can go a bit sour, or things happen where the partnership's not quite working out and you need to kind of make a move in a different direction. So I'm not saying you always have to plan for these possibilities, but definitely if it's in your cloud strategy, which every organization will have one of some sort, even if their cloud strategy is we're not moving to the cloud, right? Then you need to be thinking about these things here. And it is cloud first, but I mean, some of the biggest consumers of Vault don't even use the cloud. They're doing everything on premise and it works for them. They trust it. It underpins some of the biggest financial institutions in the world. So that's the other value add, I guess. If they trust it, well, why shouldn't we? So yeah, Right, I think I have my keyboard working now, so let's go again. So I'll just run this API call and hope my demo works. And I'm going to guess that did work. So what we're going to do is we're just going to echo the variable. What I've done is I put it inside a variable so we can reuse these things to manipulate the JSON response that we get back, right? So if I just echo that, we'll see the response that we got here, right? So what it's done is it's gone into RabbitmQ and it's provisioned this username with this password here, right? So if we head over to RabbitmQ, I'll just prove it's there. You can see that it's just generated this here. It has these permissions here. You know, it's a demo, so you probably wouldn't do that in production where you're giving it administrator rights and access to all the virtual hosts. But you know, you would do this as granularly as you require, and ops will help you out with that. Right? So now we've done that. What we want to do is we want to construct the authentication details that we're going to pass into our card to place any message on the message queue for RabbitmQ. So we're just manipulating the data that we've got here, just using JQ, right? So we're literally just echoing some stuff into different variables, and we're going to build out a final variable which has the, I called it a token here. I'm not good at naming variables, but we're essentially just going to have that ready to use in our application, right? So I'll just run that. And we have these things here, right? So the next thing we need to do is we're using the transit secrets engine in Vault, and that expects any plain text that we pass it for it to encrypt to be base 64 encoded. So that's kind of the first thing that we're doing here. So we're basically taking a plain text piece of data, and I've just put devslop meets DevOps Rob, seems pretty fitting. And we're just gonna just turn that into base 64 encoded string here. Let's just do that right now. And we'll just do some verification. In fact, what I'll do is I'll clear this so it doesn't get too confusing. And then I'll just post these two here. We've got that. So I would just echo the payload, right? Let's call it $payload. And you'll see that we now have a base 64 encoded string. Now, working with JSON in Bash, it can be tricky sometimes, right? So I'm just using JQ again, just to kind of manipulate a JSON document, if you like, to pass in with our payload, right? So I'll just run this, which is just basically going to put that into a JSON document ready for us to make the API call to Vault. I'll just run that. Okay, so what we'll have is a JSON string that looks just like that. Now, what we want to do is we want to now make an API call to Vault. So similar kind of thing, we're making a call to this endpoint. So it's the transit secrets engine. So you remember in the previous example, it was a RabbitmQ one. The action that we want to take is to encrypt the data. And I have an encryption key, which ops have already provisioned for me. They've just told me what it's called devslop, right? And all I'm doing with JQ at the moment is I'm isolating the ciphertext that comes out, because you get like quite a big JSON document back as a response, right? So we'll just copy and paste that. And hopefully we don't get any issues. So just to kind of show you what the response looks like, let's echo that, right? We'll echo $ciphertext. And here you can see this is the ciphertext that has come back from Vault. Now what you can see here is it's come from Vault, and this is version 1 of the encryption key that's been used. You can always rotate encryption keys. So you know, if you need to encrypt and decrypt data, you need to know what version of a key you need to run the decryption against, for example. So that's just all part of the string. And then you have the ciphertext there. Right? So now next, what we want to do is we want to place this on a RabbitmQ message queue. So here, again, we're just working with JSON here. We're constructing the payload for our API call. Nothing too fancy going on here. I'll just run that. No need to keep you in suspense. Okay, so we now have that in a message variable. And then finally, we're going to run this API call, which is against RabbitmQ. I mean, this is all about secrets management, so I'm not going to get into the inner workings of RabbitmQ too much. This could easily be any other message queue system. But this is this is a post request, and it's going to place this message on a queue within RabbitmQ, right? And hopefully the demo gods are with me. It looks like they are, because you can see that rooted is true. So let's just head over to RabbitmQ and just quickly have a look. And you can see we have this queue here called DevOps Rob. And in here, you can just see from the chart that there's some activity there, right? So if I was to go down here and do get messages, you'll see that there's a message here, which is the ciphertext that's come from Vault, right? So that's the producer side of things. We have another script, which is the consumer script, right? So this is going to act as another service. So we're doing the same type of things again, right? We are going to request some credentials for Vault. You know, we don't want to use the same credentials as the producer, because that's just not how it would work in reality. We're going to run these same things. So I think you've seen me do this before. So I'm just going to run this lot as one batch. Just clear this because it is a bit confusing. Just run that. And that looks like it's all good. And now we want to go to the message queue and we want to consume that message, right? So we'll just run, this is just a RabbitmQ API call. And let's just see what comes back from that. So if we were to echo $consumer, which is the variable we placed it in, we can see that it's come with the same ciphertext that the producer placed in the message queue, right? And I think if we go back to RabbitmQ, that API call, if we just close this off, we do get messages. It will say the queue is empty because it's now consumed that message, right? So now we need to give this to Vault, and we need to decrypt it so the application can do whatever it is it needs to do. So we're doing the same type of thing here. We are manipulating some JSON data. We want to create a JSON string. We're just going to run this, and we're going to use that to make an API call to Vault. Now, it's, again, still the transit secrets engine, but the action this time is to decrypt. And we want to decrypt using this cryptographic key. And, you know, we're just isolating from the JSON response the plain text data that we want to see from that. Right? So if I just run this lot, and that looks like it was successful. Well, what we'll do is we'll just echo $plaintext, which is the variable we used. And you can see that is the base 64 encoded string that we saw in the producer script. So obviously now we need to decode that, and then the application go ahead and do whatever it needs to do. So we'll just echo that and just pipe that into base 64 with the decoding flag. And you'll see our message there, which is DevSlop meets DevOps Rob. And I'm just going to pat myself on the back because I don't think anyone out there realizes I only got this working like 5 minutes before we jumped on this. So I'm super thrilled. Yeah. Right. So that's demo one. I don't know. Yeah, go ahead.
Can I ask you a couple of questions that sort of popped in?
Talk.
Okay, so encryption as a service that you just sort of demoed. Do you have what are the configuration, like how can you configure that? Like, could you just put any arbitrary text into this encryption as a, like, I don't know, like I'm sort of curious as how you would use this like in an enterprise, like aside from little small things, could you put larger things in there? Could you adjust the, I don't know, key strength, the algorithm used? Is that all part of the product?
Excellent question. Yes. So you have a choice of cryptography algorithms that you can use. So it could be SHA-256. It could be, you know, I can't remember the list. There's a long list of different algorithms that you can use to encrypt. In terms of the maximum size of data, there is a maximum. I can't off the top of my head remember what it is. I'll look it up and tweet it. There is a maximum. But, you know, there's so many different things that you could encrypt. It's not just a small string like that. For example, we had some ASCII art when we did the Hashicorp coin and the blockchain that we created for HashiConf, which is a bit of a bigger document. It can be pretty much almost whatever you need it to be. So that's in terms of the size of the payloads. I'll cover that probably in a tweet or something like that, because I don't want to give out false information at the moment. But I can guarantee there is a limit, because I've seen it before.
And it's all symmetric key based. It's all symmetric key based.
You could do symmetric or asymmetric. It's totally flexible. Totally flexible. We even have a different secrets engine, which is more enterprise. So you'd have to pay for this one, because everything I'm showing you at the moment is free and open source. So you can go out there and implement these things. But we have another one called the Transform secrets engine. And that one, what that does is, instead of just doing encryption as you've seen and decryption like this, it will do format preserving encryption. So, if you have the requirement to store data in your database, for example, in a specific format, maybe a credit card number, for example, and you have some kind of data validation in terms of the format of that data, then you can encrypt it using format preserving encryption, and then just basically transform that stuff into some scrambled data which fits the format, and then you can descramble it in a similar kind of way. There's, again, marketing are probably screaming, because the Transform secrets engine is way more powerful than what I've just said. But just from a high level, there isn't much that you can't do. I mean, with it, you can sign data. So you can just give it some data and say you want to sign it with this cryptographic key, and then you've got that signature. You could do HMACing. There's so many different things you can do with it. It's a fully fledged cryptography service, and all you're doing as a developer is interacting with the API. That's all you have to do. We have SDKs as well, which are cool, but they're under the hood. They're just using the API. So I just want to show how easy it is just to do that.
And is there a Kubernetes webhook to get Kubernetes secrets out of Kubernetes and into HashiCorp, so you could, I don't know, does that exist?
Not yet. It's Kubernetes, so you can imagine it's a topic of conversation, and it's something that some very smart people that I know are really thinking about how they can solve some of those problems there. At the moment, the integrations that we have with Kubernetes, as far as Vault is concerned, is we have firstly an authentication methods where you can use your Kubernetes service accounts as the identity provider, if you like. And the second integration is we have a sidecar injector, whereby you can get your secrets that your pods need, whatever it is, and then the pods have access to this sidecar, and they can take the secrets and consume them in the way that they need to do. And then actually there's a third integration as well, which is maybe integration is the wrong word, but we now have an officially supported Helm chart for Vault. So if you want to run Vault on Kubernetes, we have a very opinionated way of doing that. And obviously that opinionated approach is about how we believe you should implement it to secure yourself and reduce your attack surface. So you've probably seen, if you've watched Community Office Hours, you've probably seen me hang out with Jason O'Donnell. He's a great guy, big fan of Kubernetes, and he is the main author behind that. So yeah, definitely keep following us, because I'll get Jason back on. You can learn more about that.
Cool. And one last question from me. Large enterprises that have privileged access management tools in place, like CyberArk or the like, have you come across that? How do these things all interact? Because I feel like they're a little bit different, but a little bit maybe the same.
Great conversation to have. So I view things like, you used the word yourself, privileged access, right? I view things like CyberArk as privileged access management tools. I don't view Vault in the same way as that. I view Vault as an identity broker. So we're talking about traditional identity and access management. And primarily, a lot of what Vault is doing is more centered towards applications than it is humans, right? There's a lot of automation inside there. It's kind of built from the ground up for developers to solve those problems, right? Whereas you look at privileged access management tools, and you're actually talking about more human principles rather than machine principles, right? That they need to access this for break fix, or they need to do that, or you have requirements to session record, for example. So those they're different challenges, but they meet somewhere in the middle. The two are connected with each other, right?
Yeah.
So we have a tool which was just launched. Oh yeah, we're in 2021. Last year, towards the back end of last year, which we call Hashicorp Boundary. Now, it's not a privileged access management tool per se. It's more what I like to call a session broker, right? So instead of having to go through VPNs and jump boxes and all that kind of stuff there, what you do is you interface with this thing and it brokers sessions to targets. You know, that's a whole conversation in itself. I think we've got some features where it's going to interact with Vault, where it can go to Vault and say, hey, we're starting a session for this engineer to go and troubleshoot this database, for example. Can you inject some credentials into that session? So that way, the engineer is never going to know what that credential is, but the session knows enough to be able to create that, and then it will terminate it for you. And then you can add things like session recording on top of that if you need sort of some kind of audit and compliance trail. You know, these are definitely very enterprise focused problems, and you know they exist. In terms of, I won't speak too much about CyberArk, just mainly because I haven't used it in that great detail. I've come across organizations that are using CyberArk and Vault, but it's my understanding with CyberArk that I think they have a very opinionated way of how you can use their things, and maybe the interactions with something like Vault, for example, or whatever other system that you want to use to manage your secrets. I don't know if it's so open like that, but you know, I stand to be corrected on that. I'm not too much of an expert on that. Vault is.
I think you're.
Yeah. I feel like it's a different value proposition there to CyberArk. I think we're solving different problems which are related to each other, I feel.
Yeah. No, I feel you on that. I just, you know, I think it's interesting conversation just to explain the difference, human versus machine, kind of. Especially in the authentication world, that is a big fork in the road, right? Are you a human or are you a machine? So, yeah.
I mean, it's funny because the risks are ultimately the same, but they're different. And, you know, I'm still, it's something I think about a lot, and I'm trying to find a really smart way to articulate that. And it hasn't quite come to me. But, you know, the risk is the same, and even the challenge is the same, but, you know, sometimes the impact is different. You know, if a human gets hold of something that they're not supposed to have, then you know you still have the possibility of the fact that they could just be non-malicious actors, and then they could, you know, report the fact that they've got access to certain things, and then security can come in and remedy that situation, or it could be a malicious actor. So the risk is obviously a lot higher. With machines, you know, it can go in any direction. You know, if something is programmed to kind of put things out there, it could accidentally put stuff out there to the wider world, and now you're even far more exposed than one individual. But you know, sometimes the scope of an exposure there can be quite limited based on what that machine can do. So it's tough problems to kind of understand. Interesting problems, definitely. I definitely do get a thrill out of thinking about how we can solve these things, because you know, I feel like Vault has made great strides when it comes to identity brokerage and cryptography as a service, and that level of secrets management. I even feel like the privileged access management itself, there are good solutions out there that are going to help businesses solve their problems. But now the challenge is, what we want to do is we want people to be able to use whatever it is that they use within their workflows, and not tell them, okay, we can give you this, but you have to use that, for example. So with Vault, I mentioned that you could bring your own identity provider. We're not going to tell you that, yeah, you need to use LDAP, or you need to use Okta, or whatever your IDP is. If you want to use GitHub or your cloud provider as an identity provider. The point is, we've got this challenge where we need to enable security for people, and we need to enable it in a way that works for them. We don't want them to change their workflows. We want it to integrate with their workflows, right? And you know, for me, security done well, it works for you, not against you, right? And you're not going to have any great success implementing security if you don't have adoption. So workflows is, for me, one of the most important things when it comes to implementing any kind of security product out there. You know, if developers find it easy to use and they you know, aren't going too far out of their way to implement it, then yeah, they're going to adopt it. I mean, the example I've just given, if you say to a developer, implement cryptography because we have a business requirement for you to do that, versus here, we'll give you Vault, and then that will do all the cryptography. All you have to do is just call these API endpoints. You know, I'm pretty confident that most developers out there, unless you are a security developer yourself and enjoys that challenge, they're just going to go with Vault because it's all about making our lives easier. And that's, you know, from a developer's perspective, that's the value add. You know, it's got some additional benefits for the business because, you know, if the developers are adopting these things, then, you know, adoption's good, and you now have a centralized way of managing your security operations. You know, I could talk about this kind of stuff like forever because I feel really passionately about it. But yeah, I have one more demo I wanted to share with you as well, which is going to be a lot quicker, I think. So what we have here is so one time. So I gave the example in my slide whereby, you know, we have an onboarding service and we want to be able to implement two-factor authentication with it, right? So essentially, I told you it wasn't much code, but its value is amazing, right? Essentially, all we're having to do here is just make an API call to Vault, which is basically going to say create a key for this user. The user's DevOps Rob. And, you know, that's the key that we're going to use to validate whether they are authentically the principal that we think they are. So we just clear this really quickly. Just going to make this one API call, and that creates the key. All right. So that's all you have to do. Create a key. Right. So I'll just echo this just so we can see. What do we call it? Key. And you can see we have a rather large JSON response here with a barcode, right? So the nice thing about that is what we can do is that barcode is going to be base64 encoded. So we can just decode that and actually turn that into a PNG file. So what we do is if we just kind of just grab that and store it in a variable where it's decoded. And then what we can do is just run this. And now you can see it's just created this PNG file here, right? So we have that, right? So what we will do, let me see if I've got it open. I hope I do. Is we'll use 1Password. Okay, and then what we'll do is we'll create a new login here. So just do login, and we'll just call this one Vault one-time password demo. And in here, we can add a new section. So what we'll do is we'll add a one-time password here. And I hope I can do this quite easily. Scan a barcode, right? So it's not going to be so simple. Let's not make this full screen. Okay, cool. So what we can do is we can grab that and place it over there. And as you can see, it's taken that and it's configured it there. And we'll save that, right? So here you can see it's generated a one-time password, which is going to expire in a few seconds, and then it will rotate into something else, right? So now it's rotated. What we'll do is we'll run another script. So I'll just show you the verify script really quickly. And all that's doing here is it's asking the user for the one-time password. It puts that into a JSON payload, and then it makes a simple API call to Vault just to say, hey, is this valid, right? So let's just go ahead and do that. I'll just quickly clear my terminal so it's not too cluttered. I'll just make this a bit bigger as well. So I'm just going to run the entire script. It probably makes the most sense to do that. And then it's OTP verify, right? So run that, and it's asking for the one-time password. So if we just come here, we'll probably just wait 10 seconds for that to rotate, and then we'll just enter that, and then it will make the API call for us. So we have a new one-time password of 845377. All right, so we'll pop in 845377, and we'll just enter that. And then we have this response here. Just make it a bit bigger so we can see. You can see the key thing we're looking for here is that the data is in fact valid, right? So that tells us that it's a valid one-time password. If I run it again, and what was that code again? It was 845377. You can see that we get this error message saying the code has already been used. Wait until the next time period, right? So that just kind of proves that it is only for one-time use. People couldn't like sort of get that after you've used it to authenticate and then try to kind of sneak in there seconds afterwards. It's not going to have it. And I think after a little while, maybe after about another 30 seconds, it's probably going to give us another error message saying that actually the code is not valid, right? You'll get a response similar to this where it will say valid and the value will be false. So let's just see if that's rotated again. Potentially, we'll be able to do that. Hopefully. So it was 845377. And, we probably just have to wait a few more seconds. But, the point is, it's a really simple workflow. You can trust Vault as your secrets management, your centralized secrets management point of call. Everything is in one place. It doesn't matter which clouds you're concerned with. It doesn't matter what platforms you're concerned with. It can take care of your cryptography. It can take care of your authentication workflows, and it can take care of your identity brokerage and secrets management. So that's kind of the two demos I want to show you. I'll just run it one more time and see if I can show
Rob,
you.
One quick question.
There we go.
From my end. So can you use multiple identity providers at the same time?
Yes, great question. But I think I know where you're going with this. Is if you've got multiple identity providers, how do you manage the challenge of the same principal authenticating with different IDPs? Is that kind of where you're going with this?
Exactly. So I'm thinking about identity from the individual personal perspective, the human identity, but then also what I sometimes call is identity of things. So your APIs, bots, RPAs, those type of things. And so those usually are a lot of times maybe stored in different places.
Yeah. So great question. And we thought about that at Hashicorp. And we have something that is actually enabled by default in Vault, and we call it the Identity Secrets Engine. Which is odd because it actually sits more on the authentication side, but that's semantics. Now, what you can do with that is you can take a principal. So let's just say that I have an Okta account, for example, as a human, and I also have LDAP. And for some reason, I'm doing something and I log into Vault using Okta, right? But then I log into Vault using LDAP for another reason because something else has come up and I've got to do that, and it's just easier for me to do that. So now what you have is myself, a single principal who's authenticated twice through different auth methods. So what the Identity Secret Engine allows you to do is unify that identity into a single entity, right? So you can do that. But I think what you talked about is a more common use case for why you would enable different auth methods, right? So you can say that we have all of our user principals, for example. If you're a startup, maybe everyone's in GitHub. GitHub probably isn't the best place to go to be an identity provider for your applications or for your virtual machines. Maybe Azure, where your hosting this stuff is, or maybe AWS is, so you can enable that as an auth method as well. And it's only where you have the same principal authenticating through two different methods where the Identity Secrets Engine will come in and allow you to group that. Because once you have that single entity, then you can apply permissions to the entity rather than, to the specific authentication methods itself. So I hope that makes sense. But yeah, it's I think it's a challenge that a lot of organizations have faced. And I think at HashiCorp, the people behind Vault really realized that. And, identity it's a good secrets engine to have, even though I'm not sure why it's called a secrets engine.
Yeah. So it sounds like there's some correlation rules. You mentioned the different sources and you can correlate to one identity.
Yes. exactly. And there's different types of mapping that you can do as well. It can be as simple as you like, or in most enterprise cases, as complex as your enterprise organizational structure. Because we have to think about this. We have identity providers, so LDAP, for example, and organizations have been using LDAP from before I was in the industry, and it's so intertwined in their day-to-day. So it's doing more than just being an identity provider for them. It's actually got like their group policy in there and what a user is enabled to do and all that kind of stuff there. And they're grouping users, which is like standard practice in the industry, and they're permissioning against these groups. So who wants to do that twice? I've got everything in LDAP. Not only do I have all my users, I have all my groups, and all the permissions are based on those groups. Why do I then want to go into another system, Vault in this case, and then provision those same users, create those same groups, and then put permissions against those groups there? Because now what you have is a management overhead. If you change it in one place, then you've got to go ahead and change it in another place, and then you have configuration drift, and there's these challenges here. So Vault will enable you to map these groups to a group in Vault, for example. So if something changes in LDAP, for example, it would change in Vault. So it makes it easy just to remove someone from a group should they not need to access something anymore. And you don't have to worry about, is that reflected in Vault? Vault will read that and take care of it. So that's definitely another enterprise challenge that we've sought to solve, and that's all available in open source. Everything except Transform that I've mentioned today is open source. It's free.
And within the Vault, is it role-based access controls? So could we have, I could see use cases for risk teams to go into the Vault potentially, but maybe just reporting type of access. So does it have that granularity?
Yeah, so how we do permissions in Vault is we have the concept of policies, right? So a policy can be as granular as you need it to be. So remember I mentioned in the API call that everything is path-based. So you had transit, you had this key, and you had the action, right? So what you do is you're giving a policy a path, and you're saying that in this policy, anyone who has this policy assigned is enabled to do these actions with it. So in general, we have, I think it's create, delete, list, read, and update, right? So I think it's kind of the permissions are actually based around kind of the whole API structure of how you would make API calls. So you would just make quite granular policies based around that according to the endpoints. And that's great, but that introduces another challenge. How many policies do you need to create? If you've got an enterprise with 5,000 employees, for example, how do you manage that level of policy? So the good thing about the policy engine within Vault is it allows templating as well. So if you need to update a policy, imagine having to go through 5,000 policies to update them because something has come to light or compliance have seen something and they say, no, that's got to change, and you have to go through 5,000. It's not life, is it? So instead, being able to update a template and then it reflects down to all the policies is a much smarter way of working. That's what we want to do. We want to work smarter, not harder, right? So when it comes to security, working smart is always going to win, because if something's going to take a long time, then mistakes are going to happen. We're only human. Like, we're the weakest link in this whole equation, right? So if a template is approved, then the template is approved, and you can have faith that the wider policy management is approved. You don't have to approve like PRs to change certain things or whatever it is, because the process itself has a high level of approval. So we have that functionality within Vault, but it's all about how you implement it. So you need people that have the right kind of view of the problem to help with that.
Thank you.
So just to clarify, so role-based authentication is possible on Vault. I didn't get the answer for that one.
Yeah, sorry, okay. I kind of spoke like a politician. I didn't answer the question, but acted like I did. So I apologize. No, it is, right? You. So like I said, so the policy is a role. That's the way to look at it. The policy is a role. I gave the example earlier on of app role, and you basically create a role for each application, and that role says that they can do these things because it has these policies attached to the role. So that's kind of the view that we take on it with Vault.
Thank you. Makes sense.
Do you have any questions in chat?
I'm looking right now.
There's the last one, I guess, from Security Grid. Can it work across AD without trust established, federated per se? For example, organization one display.
So, you don't need to implement like. Let me just add a disclaimer out here. I haven't implemented the LDAP or Active Directory auth method in a couple of years, so my memory is a little bit hazy, right? But the last time I did it, you don't need to actually do any kind of federation or anything like that. Active Directory itself has an API, which is all Vault is interacting with. So you're going to give it a bunch of details for it to make the API call to configure that connection there. I think if you've more than likely got TLS enabled on it, so you need to give it the TLS details. You need to give it, I can't remember what the configuration details are. I think there's some kind of account that you need to give it, and then you need to tell it at what point in the directory structure that it should start reading from, and then it will kind of read downwards. So if you have like this level of your directory structure has these organizational units, then it should read from this level and below, or maybe you want to skip this level and start from there. That's just down to your individual implementation. But it was pretty straightforward once you have someone within the organization who's well versed with your individual Active Directory implementation. Once they understand like the structure of how you can access Active Directory and how you can get data out of it and all that kind of stuff there, you know exactly what details you're asking for, and they'll know how to get the details for you. I'm not an AD engineer myself, so I was literally like, hey, Nick, can you give me these details? And Nick knew exactly what he was doing, so he was like, sure, and that was that. Yeah, there's no real complication in that setup. It's pretty straightforward. You just configure some stuff in an API call, and you're good to go.
Cool. I think we are out of questions in the chat. I think we've certainly asked you a ton, so I think we're good here. This was great. I really appreciate you walking us through this product, and it's really great to see something that is like you could just use it now. It's like free and open source. I know we were talking about like other tools on here, but it's so great to just see pretty good commitment by the Hashicorp team to in the open source world. So yeah, just want to call that out. We love open source. It
goes back to the whole security is like everyone's responsibility. So if you're going to make these cool tools that are going to help people ease their security problems, I think to have an open source version, I almost feel like it's our responsibility to have an open source version. Enterprises will obviously have enterprise needs, and they can go and get enterprise products. But in terms of open source, like we all have security requirements, and we should be able to just access the bare minimums at the very least. And I think Vault gives you a lot for an open source product, like a hell of a lot.
Definitely. And maybe we could like clone a bunch of Robs and have them go into every security vendor with that attitude. I
keep telling my wife I'm one of a kind.
Make the vendors run bankrupt, right?
Well, they probably still do pretty well. Enterprise is gonna enterprise.
Yeah.
Hard agree. Hard agree.
Thank you so much, Rob. You were right. There's so much to cover, and there's things that you didn't even cover. So we ran a little long, but I think that was totally worth it. We're past our usual hour, and people can the video stays on their YouTube channel. So please go back if you missed part of it and you had to leave us. Before we wrap up, thank you to our sponsor Solvo for this episode. Thank you for Shanisa for being for your first show. Bravo. That was you're great. I'm really happy that you joined us, really added to the conversation, same for all our co-hosts. What else for next week? I want to let you know who's coming with next week. Okay, so we have David Handry coming next week, talking to us about cloud security and IAM for developers. Yeah, we like to cover IAM. So yes, we have a session about an hour next week with David. Please follow us on social media, whether it's Twitter, LinkedIn. Meetup is a great place to know what we have coming up. And yes, we'll see you next week. Rob, please don't hang up right away. We want to say a proper bye. Thank you, everyone, and see you next week.